Hi there, and welcome to the Air Equipment LLC YouTube channel. My name is Bill Dunn, and I am the Engineering Marketing Manager here at Air Equipment, located in lovely downtown East Hartford. And today our topic is Energy Recovery Ventilators, or ERVs. At Air Equipment, we are the representatives here in our territory for Renu Air, a really terrific manufacturer based in Wisconsin that makes a really quality energy recovery ventilator product, many different sizes and airflow capacities. In our first segment, however, we're going to talk just in general terms about why it is that we need and use energy recovery ventilators on our commercial and industrial projects. This first illustration here represents a typical commercial or industrial building. With all buildings, there is a requirement for exhaust air, represented here by this completely out of scale exhaust fan on the roof. I'm pretty sure most exhaust fans are not the same size as a two-car garage, but however, for our purposes, we're just showing that there are indeed exhaust fans on buildings. And what those exhaust fans do is they're required to remove air from the building, say from bathroom areas or dining areas, kitchen areas. There always is a requirement to have exhaust air leaving a building. Now, in addition to sending the air out of the building, what happens with these exhaust fans is that they are sending energy out of the building, BTUs. In the summer, when the air inside the building has been air conditioned and is cooler, the exhaust fans are sending cool air out to the atmosphere. In the winter, the air inside the building has been heated up, and so the exhaust fans are sending warm air out into the cold atmosphere. That's energy being taken out of the building and sent away, which really means that what's being sent out of the building are dollars, because it costs money to create cool air in the summer and warm air in the winter, and if we send that out to the atmosphere, we're just sending money right out the window. You can imagine those exhaust fans, instead of just shooting air out of the building, they're shooting a big stream of dollar bills just fluttering out of the building. Now, in addition to the exhaust air requirements for a building, there are also our outdoor air intake requirements, as illustrated by this completely out of scale, yet again, supply fan. We need outdoor air to bring into our building to meet our ventilation requirements and for makeup air and for other air pressure balancing reasons, but there always is a requirement to bring in outdoor air into the building. Now, that outdoor air is going to be at whatever temperature it is outside. In the middle of the winter, it could be 0 degrees. And in the summer, it could be up in the 90s and very humid. So, before we can take that outdoor air and distribute it throughout the building to meet ventilation requirements, that air has to be conditioned. In the winter, we have to raise the temperature of that outdoor air up to the 85 to 90 degree range before we can spread it out throughout the building. In the summer, that hot and moist air has to be conditioned down, and typically supply temperature for an air conditioning system is about 55 degrees. So that hot, moist air has to be dried out and cooled down before it can be distributed in the building. This again requires a lot of money. It costs money to heat up freezing cold air, and it costs money to cool down warm and moist air in the summer. So we have this situation where a lot of money is being exhausted out of the building, air that we've already conditioned, either warmed it up in the winter or cooled it down in the summer, and now we're just sending it out to the atmosphere. And at the same time, we're bringing in outdoor air and spending a lot of money to condition it to make it acceptable to be distributed throughout the building. So the idea of energy recovery ventilation is that we would try to cross those two airstreams, the exhaust airstream and the supply airstream, cross them so that we can transfer the heat from the exhaust side to the intake side and recover some of that energy that we've already spent money to create. Now, I know in the movie Ghostbusters, it is very bad to cross the streams. However, when it comes to energy recovery ventilation, crossing the streams is exactly what we want to do. And if we do that, if we can capture some of the energy out of the exhaust airstream before it leaves the building and transfer that to the outdoor air coming into the building, what we do is, instead of having 0-degree air in the winter, maybe we can get that air temperature up to about 50. So instead of going from 0 to 85 or 90, now we only have to go from 50 to 85 or 90, which is a lot less expensive. And in the summer, instead of going from the mid 90s and very humid down to our 55-degree supply temperature, now if we're going from, say, only in the mid 70s, 75 or 78 degrees down to 55, it costs a lot less money. So that is, in a nutshell, the reason we do energy recovery ventilation. We capture some of the energy we've already spent money to create and transfer it to the outdoor air coming into the building and reducing the utility bills significantly. In our next segment, we're going to talk about some various techniques that are used with the emphasis on Renu Air's static plate enthalpic core, which is a very, very efficient, very economical, and very low maintenance way of doing this energy recovery ventilation. So make sure you stay tuned and watch part 2 of this series. Thank you.